Hello everyone, Assalamu alaikum. In this tutorial, I'm going to talk about network topology, its types, advantages, and disadvantages. So at first, let's talk about what a network topology is. So network topology basically refers to the structure of how a network is connected. So basically it means how the devices or the cables are connected with one another in a network. Alright, so there is an example. So basically if you think about a city, and then the topology can be defined as the roadmap of that city. So if you want to maintain a city, then you'll have to design how the roads will be built within that city, or how different types of buildings or shops may be built in that city. All right, so you are basically designing the total roadmap for a specific city. So this is what we do in terms of network. All right, so in a separate network, we always need to find out the perfect way to create a good structure for our network. So the way how we are actually designing our network, it is called network topology. All right, so there are different types of network topology. One is mesh, then another is star, then there is bus and ring. So basically there are four types of network topology, and I'll describe all four of them. So at first, let's talk about mesh topology. Okay, so in mesh topology, basically there are different stations in a topology, and in case of mesh topology, all the stations are connected to one another. So right here there are 5 stations in this diagram, and you can see that all the 5 stations are connected with one another. So this is how mesh topology is created. Okay, so every device has a dedicated point-to-point link to every other device. So as you can see, if we look at those two devices over there, right there where my cursor is, so this station and this station, they have a point-to-point connection between them. All right, only this connection. Okay, and then this station has a point-to-point connection with this station and also with the other stations. All right, so basically all the stations are connected with one another using point-to-point connection. And you can see there is a formula right here, n into n minus 1 divided by 2. So basically this formula indicates the number of cables necessary to build a mesh topology. Alright, so n indicates the number of stations in our topology. So if there are 5 topologies, if there are 5 stations in our topology, then if someone asks that how many cables do you need to create such a topology, then we'll just put 5 at the place of n, and then we'll calculate using this formula, and then we'll be getting our result. All right, so for example, if we put 5 here, then 5 minus 1 will be 4. So 4 into 5 will be 20, and 20 divided by 2 will be 10. So we'll be needing 10 cables. So let's verify whether we're correct or not. So 1 2 3 4 5 6 7 8 9 and 10. All right, so as you can see, this formula works perfectly. So you need to remember this formula, because sometimes in exams you might be given a question where you are asked to calculate the number of cables needed to build a mesh topology, and then you will need this formula to calculate the answer. Alright, so now I'm going to talk about the advantages and disadvantages of mesh topology. Alright, so the very first advantage of a mesh topology is actually that it guarantees that each connection can carry its own data load. Alright, so if you take a look at the diagram of the mesh topology, then you will see that all the stations are actually connected with one another with a point-to-point connection. So if any of those stations want to send data to another station, then it will have a dedicated link between them. Alright, so this is what is told here. Each connection can carry its own data load. Alright, then secondly, a mesh topology is robust. Alright, a mesh topology is robust. So if one link becomes unusable, then you can just disconnect that link. That will not have an effect on the other links. All right, so if this connection right here doesn't work, then you can just take out this link, and but it will have absolutely no effect on the other links in this topology. So thirdly, there is the advantage of privacy or security, because as you can see that all of those connections are point-to-point connections. All right, so if this station wants to send data to this station, then it can send the data using this link only. So all the other links, all the other stations, they will not know what type of data is being sent from this station to this station. All right, so this will be a point-to-point connection. So the other stations will not have any idea about the data being sent from here to here. All right, so this gives a sense of privacy or security to the user. And finally, you can see that this point-to-point structure makes the fault identification and fault isolation easy. That means if you can see that there is any kind of fault in your topology, then you can easily find out where the fault actually is, because all the stations are connected with one another using point-to-point connection. Basically all the stations are connected with one another using a single link. All right, so if there is a specific problem, then you can just go into that specific section very easily. All right, so if you want to send data from this station to this station at the bottom here, so if that data cannot be sent from this station to this station, then you will definitely know that the problem resides in this area, in this link. All right, so since there is a direct link, so data will be sent over this link. So if the data can't be sent, then you will automatically know that there are some type of problems in this link. All right, so you can easily find the fault, and you can easily try to restructure the cable. All right, so these are the basic advantages of mesh topology. So now let's talk about the disadvantages. The very first and obvious disadvantage of mesh topology is that you will need a lot of cables. All right, so as you can see, the main disadvantage of a mesh are related to amount of cabling, because every device must be connected to every other device. So basically all the devices are connected with one another. So for that reason you'll be needing a lot of cables. All right, so due to a large number of cables, the installation of the whole topology and the reconnection or reinstallation becomes extremely difficult. All right, so this is the very obvious disadvantage of mesh topology. And then there is another thing called availability of space, all right, or storage, because as you can see in the diagram. All right, so let me just move into the diagram. In the diagram, as you can see, there are a lot of cables between the among the stations. All right, so only for those 5 stations you'll be needing 10 cables. So imagine what how many cables you will be needing if there are more than 100 or 1,000 stations. All right, so a huge number of cables, and for that huge number of cables you'll be needing a huge space too. All right, so this is another disadvantage. Okay, so and the final disadvantage is basically that the installation and the whole structure of mesh topology is actually quite expensive, because as you can see the mesh topology needs a lot of cables, and whenever you want to use more cables you'll be needing more money. All right, so the structure is actually quite expensive or costly. So these are the main disadvantages of mesh topology. Okay, so now we are finished with mesh topology. Now let's move into the next topology, which is known as star topology. All right, so in star topology there will be a central device. Basically this device is known as a hub. So the hub is basically a network device, something like a router or a switch. Okay, so in a hub there are multiple ports, and from those ports some stations will be connected using a link between them. All right, so you can see from the diagram that this is the hub, and there are 4 different ports, and from those ports a connection is going to the stations at the other end. All right, so there are 4 ports, so 4 stations. So this is basically basically looks like a star like structure. All right, so that's why it is called star topology. So now that we know what and how a star topology looks like, so let's talk about the advantages and disadvantages of a simple star topology. Okay, so at first, the advantages. So a star topology is definitely less expensive than a mesh topology, because in star topology we don't need to connect all the stations with one another. So uh, well, as we can already see that our cables have already gone down in numbers, so we need less number of cables than the mesh topology, definitely. So that's why this topology is less expensive than the mesh topology. All right. Okay, so another thing is that the less number of cables actually helps in another perspective. It also makes this topology easy to install and reconfigure. Alright, so since there are less number of cables, so if I want to reconfigure this structure, then I can just move one cable and move one station, and then I can reinstall it again without much hassle. Alright, so this is another advantage. And finally, the other advantage is known as robustness. Okay, this topology is also robust like the mesh topology. If one link fails, then only that link is affected. Okay, so what does it mean? It means that you can take a look that there are 4 different ports, so 4 different stations are connected using those ports. So let's talk about the very first port in the leftmost side right here. All right, so if there is a problem in that specific link, all right, if there is a problem in that specific link, then we can just disconnect this link and this station from our overall topology. We don't need to touch other devices. All right, so if there is a problem in a specific link, then we can still run the topology with other links and other stations. We don't need to bother with the others. All right, and others don't need to bother with that faulty one. All right, so this is how it provides robustness to the user. So this basically provides easy fault identification and fault isolation. So as long as the hub is working, it can be used to monitor link problems and bypass defective links. All right, so these are the main advantages of star topology. Alright, so another thing I need to tell you is that whenever one station wants to send data to another station in this topology, then that station needs to send the data to this hub at first, and then the hub will resend the data to the other station. Alright, so this is how this topology actually works. So now let's talk about the disadvantages. Okay, so the very first and obvious disadvantage of star topology is the dependency of the whole topology on one single point. In our case, it's the hub. So you can see from the diagram that this hub controls all the stations right here. All right, so if somehow the hub becomes faulty, if somehow there is a problem in the hub, then the whole topology goes down. Okay, so this is the first disadvantage of star topology. And another disadvantage is actually that even though a star topology requires far less cable than a mesh, but still it needs a good number of cables. All right, so basically it needs more cables than some other topologies like ring or bus topology, which will be reading just in a bit. All right, so in that sense, this is a disadvantage of star topology, that even though it is more advantageous to use star topology than the mesh topology, but compared to some other topologies like ring or bus topologies, then this star topology has some disadvantages related to the number of cables. Okay, so these are the advantages and disadvantages of star topology. So now that we completed this topology, let's move on to the next one, which is the bus topology. Alright, so let's talk about the bus topology. The bus topology is a simple topology. You can see from the diagrams that there is a backbone network, there is a backbone connection right here, the black bolt line over here, the cable end. These are indicating the cable ends. There is one end and there is the other end. So this is a backbone connection. Okay, so this cable works as a backbone connection, and then the individual stations are connected with this backbone connection over here. Okay, and all of those stations are connected with this backbone using a point-to-point connection. Okay, just like mesh topology. So using point-to-point connection. Okay, so now we can see that there are some other things written over here like drop line and tap. So let's talk about those. So the drop line is basically the connection between the station and the backbone. Okay, so this is the link, and this link is known as the drop line. And what is tap? Tap is basically the device which connects the station with the backbone. Okay, so this is some kind of joint, you can say. Okay, so this is some kind of device which helps the station to get connected with the backbone. Okay, so you can see that whenever you add a new station, you need a drop line and a tap to get connected with the backbone. Okay, so this is the basic structure of a bus topology. So now that we understand the basic structure, I'll be talking about the advantages and disadvantages. But before going into that, let me tell you another thing, that on this backbone link over there, usually a signal travels continuously. Okay, so whenever a signal travels through this backbone connection, then it becomes weaker and weaker as it travels further and further. So for that reason, there is actually a limitation of how many taps or how many stations you can actually use in your topology. Okay, so there is a limit on the number of taps a bus can support, or and on the distance between those taps. Okay, so whenever you want to build a bus topology, you can't just continue adding more stations and stations. All right, so you have to stop somewhere, because there is a limitation about how many stations you can connect to a bus topology, or how many taps you can use in a bus topology. Okay, so now let's talk about the advantages and disadvantages. Okay, so at first, the advantages. So the advantages of bus topology include ease of installation. Okay, you can see from the diagram that installing this topology should be relatively easier, because you can just set up a backbone connection, and then all the stations will be connected with this backbone connection using point-to-point connection. Okay, that's it. So this is quite easy, and this ease of installation is definitely an advantage. Okay, so in bus topology, we can see that a bus uses less cabling than mesh or star topologies. All right, so the bus doesn't need more cables. It usually needs less number of cables for than mesh or star topology, as I can see from the diagram. And there is also an example in a star. For example, 4 network devices in the same row require 4 lengths of cable reaching all the way to the hub. Okay, what does it mean? It means if we go back to the star topology, you can see that there are 4 different stations. So for those stations to get connected to the hub, you need 4 different lengths of cable to connect those stations with the hub. All right, but in case of bus topology, you can see that this redundancy is eliminated. Only the backbone cable stretches through the entire facility. That means if you want to build a topology, then you don't need to create you don't need multiple number of long cables in your topology. You just need one long cable throughout your topology, and then all the other connections can be given with relatively shorter cables. All right, so like this one. Okay, but you only need one long cable. But in case of star, that's not true, because in case of star, you will be needing long cables. You'll be needing different number of cables, so there will be more amount of cables in your star topology. But in case of bus, you just need one backbone connection, so you'll be just needing that long cable, and the other connections can be given with using short cables. All right, so only the backbone cable stretches through the entire facilities. Each drop line has to reach only as far as the nearest point on the backbone. Okay, so these are the advantages of bus topology: the ease of installation and less number of cables. All right, so now let's talk about the disadvantages. Okay, so the disadvantages include the difficult reconnection and fault isolation. Okay, So let's talk about the difficult reconnection part at first. I've told a few moments ago that the bus topology is built in such a way that you have to think about the limitations about the number of stations or number of tap lines you are using in your topology. So whenever a bus is built, then at that specific moment the network engineer has to think about the most optimal structure that he can build at that specific moment. So whenever a bus topology is built, it is built thinking about the optimal structure. All right, so whenever you need to change it in future, then it becomes a problem, because in that case you'll have to think about the limitations, think about the number of taps or number of devices. So this becomes a little bit difficult to reconnect all those devices again, and thinking about all those limitations. All right, so that's why the reconnection part is actually a disadvantage for the bus topology. All right, and the second one is fault isolation. So if there is a problem in our bus topology, if there is a problem in our backbone connection, then it will create some type of interference throughout all those stations. All right, so if there is a problem somehow in our backbone link, then because of that that interference, will not be able to understand where that problem was actually originated. All right, so where that problem actually originated, we will not understand that. As a result, we will not be able to identify the actual fault location, because whenever there is a problem, there is a data corruption or some type of problem, or there is any kind of external damage in the cable, in that case this backbone cable will create some type of noise or interference throughout this whole topology. So as a result, we'll not be able to find the actual location of the fault or of the problem, and thus the fault identification or the fault isolation becomes a bit more difficult than the other topologies. All right, so this is another disadvantage. Okay, so these are the basic advantages and disadvantages of the bus topology. So now that we are completed with it, so let's move on to the final topology, which is known as the ring topology. Okay, so in a ring topology, each device has a dedicated point-to-point connection with the other two devices on either side of it. Okay, what does it mean? So let's say there is a station right here, and it has a station on its left and one station on its right. Okay, so this station has a point-to-point connection with the left one over here and also with the right one over there. Okay, so a signal is passed along the ring in one direction only. Okay, so this is basically unidirectional. A signal is passed throughout this ring like structure over here, and it goes in only one way. Okay, from device to device until it reaches its destination. Okay, so let's say I want to send the data from this station over here. Okay, so let me just mark in. So let's say I want to send data from this station over here to this one, from from green to the blue one. Okay, so how will it work? So basically what will happen is that, let's say that my connection works in this way only. In that case, this station will send the data to this station at first, then this station will send the data to this station, and then this station will send the data to this final destination. Okay, and this is unidirectional. So I just assume that in my topology the data goes in this way. All right, so in your topology it may be different, okay, but it will always be unidirectional, always moving in the same direction. Okay, and you can see that there are some other devices like repeaters. So let me tell you what it does. So whenever a signal travels from one device to another, so sometimes this signal may become weak. Okay, so this repeater actually regenerates the signal and then send the bits to the other station. All right, so let's say that the signal starts traveling from this station to this station. So the signal goes from this repeater to this repeater over here, and when it goes into that goes to that repeater over there, then this repeater regenerates the bits of that signal and then passes it again to the next one. Okay, so then it goes to this repeater over here, and then this repeater regenerates the bits again, and then it sends the bits to the final repeater, and then the repeat from that repeater the data goes into the station. Okay, so this is how the ring topology works. Okay, so let me just erase those. Okay, so now that you know how the ring topology works, let's talk about the advantages and disadvantages. Alright, so the very first advantage is actually the installation part. A ring topology is relatively easier to install and reconfigure. Just like the in case of installation, we can actually compare it with the bus topology. The bus topology is also easier to install, and the ring topology is same as that one. Okay, so a ring is relatively easy to install and reconfigure. Basically, each device in the ring topology is linked to only its immediate neighbors, one in the left side and one in the right side. Alright, so let me just move into the diagram. So you can see each device is connected to its left device and the right device only using point-to-point connection. Alright, so if we want to add or delete a device, then we just need to change two connections, because all the stations are connected with only two devices, one on the left and one on the right. So whenever we want to add a connection, we just need to think about two specific devices, not the whole topology over here. Okay, we just need to think about this and this station over here. We don't need to think about all of those stations, all the whole topology over there. All right, so this is one advantage. And another one is reconfiguration. So we can actually reconfigure this easily, as I have just told that if we want to reconfigure or reconnect something, then we just need to think about two devices, not the whole topology. Okay, and the only constraint here are media and traffic considerations, maximum ring length or number of devices. Alright, so the only consideration you need to think about when building ring topology is the ring length, how long your ring will be, or how many devices will you connect. Alright, that's it, nothing else. So other than that, there is another advantage which is known as fault isolation. Okay, so basically, in a ring topology, a signal always travels in the ring-like structure. Okay, a signal always runs in the ring. A signal is circulating all the times. So at a specific time, if one device does not receive a signal within a specified period, okay, so let's say that this station at the right over here, so this station is not receiving the signal for a specific period of time, let's say for 1 minute or 2 minutes. All right, so in that case it will issue an alarm to the whole topology. Okay, so that is what's written over there, that if one device does not receive a signal within a specified period, it can issue an alarm. Then the alarm alerts the network operator to the problem and its location. Okay, alright, so if I want to show you the fault isolation part using the diagram, then let's see. So usually there is a signal which runs through the ring-like structure all the time. Alright, so all the stations are receiving this signal. So let's say that for a specific amount of time, this station over here is not receiving this signal. Alright, it's not receiving this signal. So let's say that it has not been receiving any kind of signal for 1 minute. So if something like this happens, then this station will issue an alarm, and that alarm will ultimately notify the network engineer or the network operator that there is some type of problem in this topology. Okay, then he will identify this problem and try to resolve it. Okay, he will also be able to know where the problem originated, because the alarm will be coming from the specific station which didn't actually receive the signal. Alright, so in our case this one, so the network operator will definitely know that where the problem actually originated, and he will be able to identify the fault and solve it easily. Alright, so this is how the fault identification part is quite relatively easier in ring topology. Okay, so now let's talk about the disadvantages. Okay, so the very obvious disadvantage is unidirectional traffic. Okay, unidirectional traffic. So as you can see in the diagram that let's say our traffic moves only in this way. Okay, so yeah, just like this one. So if I want to send a data from this device over here from 1 to 1 2 3 1 2 3 4 5, yeah, so let's say I want to send some data from 1 to 5, from station 1 to station 5, and since we are using only unidirectional traffic in ring topology, then the data will have to move using this path over here. So it will have to travel from this station to this one, then this one, then this one, and this one, and then this one. All right, so as you can see that this path is quite long. Okay, where it could have easily traveled using this path over here, so from this station to this station and then to my destination. So in that case there will only be well, two intervals. All right, so one from here to here and then from there to there. Okay, so this will be a much shorter path over here. So let me draw this using another color. So if I could follow this path, then this would be much shorter than the path I'm taking right now. Okay, so since we're using only unidirectional traffic in ring topology, that's why we can't use this path. We have to use this one, so even though it is the longer path. All right, so this is one possible disadvantage. And the other disadvantage, okay, the other disadvantage is the ring itself. Okay, so if there is a break in the ring, okay, such as a disable station, then it can disable the entire network. Okay, so let's see. Okay, so this is the ring. So if there is some type of damage in the ring, maybe a station is disabled or something, then the whole topology becomes unusable for some time. So why is that? Okay, that's because let's say that this station went down. All right, so since this station went down, so if I want to send data from this station from 1 to 5 over here, and my traffic goes like this, then you can clearly see that my traffic will go from station 1 to this station over there. But since this station is disabled, so this station will not receive anything and my data will just lose its way. Okay, so it can't go far from there. Okay, it can't travel from this station to this station. If I number them, it's 2, it's 3, and it's 4. So if I want to send data from 1 to 5 over there, and if my station 2 is disabled over there, then my data gets lost when it travels to station 2. Okay, it can't travel further from this station. Okay, since this is disabled. So this is one problem why a fault in any kind of station will make the whole topology unusable. Okay, so this is another disadvantage. However, as we have already talked about two disadvantages, both of these disadvantages can actually be solved. Okay, so we talked about the unidirectional traffic. So this can be solved using a dual ring topology. Okay, a dual ring topology, that means a topology where you can use bidirectional traffic. That means you can use this way, or you can also use this way. Okay, in that case that unidirectional problem is actually solved. All right, so this is how you can actually solve the unidirectional problem. And then there is another one which is the break in the ring. So there is a situation where you can actually use a switch like device which can actually close off the break, which can actually temporarily repair the break so that the network can at least run for that specific time. Okay, so this is how you can solve the latter disadvantage. Okay, so these are the basic advantages and disadvantages of ring topology. So we have already completed all the 4 topologies, how they work and what their advantages and disadvantages are. So now let's talk about a different topology which is known as the hybrid topology. So as you can see from the name, that hybrid. So what does hybrid mean? Hybrid means that you are mixing up different topologies and create a new one. Okay, so a network can be hybrid. For example, we can have a main star topology with each branch connecting to several stations in a bus topology. So just like in our figure here, we are using a star topology and bus topology. We are using both of those topologies, and we have created a new one which is known as the hybrid topology. You can see that these parts over there, where I'm creating green rectangles, so these look like bus topology. All right, however, when you come to the leftmost side over there, okay, so let me just change the color. Okay, so right at this part where I'm creating a red mark, so you can see that there is a hub and there are ports and connections going from those ports to outside. So these look like star topology. Okay, remember, in star topology we use a hub, and from that hub connection goes to the stations. All right, so this looks like star topology, but this part right there looks like bus topology. So we are using both topologies together, and we are creating a new hybrid topology. So you should practice it yourself. You should try to build other hybrid topologies using multiple topologies together. Okay, you can also look over the internet to find more details about hybrid topology. All right, so that's it for this lecture. Thank you for watching.